G'day there, my name's Hef and I'm going to go through what TOR is. So what is TOR? TOR stands for the onion router. Over the last couple of years you've probably noticed a rise in the potentiality of governments to be very, very mischievous. I thought, what a great time to help you hide what you want to do on the internet if that's what you need. So the onion router is probably the easiest way to do this online. Now, it's not a catch-all, and just because you use it doesn't mean you will be guaranteed to be safe. How does TOR work? Over here we've got the user, and it could be a phone, could be a computer like a desktop or a laptop, and over here we have the TOR network. Each of these green boxes is a router inside TOR. These red ones are also routers, but they're exit nodes as well. These exit nodes are the ones that will communicate outside of the TOR network on your behalf, kind of like the proxy. So when the client initially wants to set up a connection through TOR to the website, it needs to establish a circuit inside TOR first. Now, it's done by some complex algorithms. And what happens is, we'll find a route through TOR. We'll find some routers to connect to. So we've got A, B, and C. So 3 is pretty good. To A, down to B, and then to C, from C to the web. This is our circuit. It's bidirectional, so when information comes back from the web, travels back the same way it came, back to there. Pretty cool. Now, if we were just going to have these pass the message through, each node would be able to see what we're doing. That's not really going to help us. This is where the onion router really does some cool stuff. So when we set this circuit up, we also need to establish some encryption keys with each of these nodes so that we can encrypt the message and pass it to these nodes and they know how to unencrypt it. So I'm going to have 3 types of encryption here. 1, 2, 3, possibly 4 if you count HTTPS on the website. So it's an encrypted link to the web page. When our client's getting its message ready, it makes an onion. In the center of the onion is the message. In this case, this message is to return a website for us. Our client will prepare this message by encrypting it 3 times. So we're going to have 3 layers. The first layer is going to be C. The second will be B. And the first will be A. Yep, and so when the message goes through, it gets sent to A has the key, so it's able to decrypt it. Alright, has a look inside. When it gets that information, it's able to see where it needs to send the message next, and also what the message is. However, the message is at least 2 more layers of encryption, so it's not going to be very useful for it. Then it goes to B. B unwraps the message. And it goes to C. Now the message traveled to C. We've decrypted it. We have the message, so we know where we want to send it, to the web, to a particular site. And then it does it, sends the message back or the response back from the website. And when it does, C, which grabs it, packages it up in a form of encryption, and then sends it through. Same thing happens again at B, and finally at A. At which point the message just traveled back through the circuit, back to the client. The client has all the keys and is able to unwrap that onion. It has the response from the web now, and they can view the page. If they need to do anything else, they'll shoot each subsequent message through. The circuit will remain for the session and will be destroyed and a new one created for any future sessions. The biggest vulnerabilities can come here, where you're using an exit node and going to the web. If these sites aren't encrypted and you're logging in, then your password and username are visible at C. If the websites you go to have SSL, then they'll be encrypted. The exit nodes won't be able to see what it is that you've sent them or what they're sending you. It'll just know to send it back and forth. The more routers you use in your circuit, the longer it will take to get to the destination. So if you were to have 15 routes in your circuit, it would be very slow to use. Each of those need to travel to the server. They could be in all different places around the world, so each time you could have a few hundred milliseconds. You add that up and it does get quite slow if you have too many. What about TOR's hidden services? The dark web. The difference with these is that when you set up your circuit, it doesn't need an exit node to reach the web. There's a service that exists inside the TOR network. And so we'll set up our circuit. The same works. The message is encrypted and gets decrypted along the way to there. And then when the message returns, the same thing happens. It gets encrypted all the way back. And then the client will decrypt it and get the message. With the hidden services or the dark web, you will need to know the URL of the service. There's no broadcasting mechanism, so if you create a dark website, to broadcast that to the dark web. So you will have to have the URL for the site that you're wanting to visit. It's a .onion site and nothing leaves the TOR network. Thanks for watching, guys. I hope you got something out of the video. Don't forget to give us a like, subscribe, and I'll catch you next time.